Hello and welcome to the tutorial for the NVIDIA Omniverse connector. In this part, we will take the first steps with the connector and will learn to visualize scenarios in real-time and high quality in the Omniverse. To work with the connector, the USD composer must be started first. And as soon as this is running, EMA can be started and your scenario can be loaded. I use a typical EMA scenario here for the tutorial, but generally the connector works with all EMA scenarios. Go to Import, Export in the EMA menu bar and activate the toolbar under NVIDIA Omniverse connector. It appears at the top right of the window. If a server other than localhost is used, the path can be specified here if required. To start the transfer to the Omniverse, click the button with the NVIDIA Omniverse logo. Now the connection to the Nucleus server is established and the EMA file is transferred via the interface. A USD file of the EMA file is now created in the set path. I use the localhost server here and can therefore find the EMA USD file under localhost projects. Select the EMA file and the scene will be loaded. So let's have a look at the user interface of the composer first. In the center of the screen is the 3D view in which our EMA scene is visualized. To the right of this is the object tree. At the bottom there are various browser tabs, for example to import data or add materials, and at the bottom right the object properties can be edited. To play the simulation, use the space key or the symbol on the left side of the window. To also see the EMA camera flight, I click on Perspective at the top of the 3D view to change the camera and activate Camera 2 from EMA. Now the camera flight is also played back. In the 3D view, you can look around in a similar way to turning your head by holding down the right mouse button and moving the mouse. The camera then rotates around its own center point. You can also walk relatively to where you're looking by holding down the right mouse button and pressing the W, A, S, D, Q, and E keys, or the arrow keys plus the page up and down keys. Panning works by holding down the middle mouse button and moving the mouse similar to EMA. And you can also scroll your mouse wheel to zoom in and out of the scene. It's also possible to focus on a specific object by selecting an object and pressing the F key. This object can be orbited by using Alt plus left click. In the toolbar to the left of the 3D view, you can choose different selection modes. Use the Model Selection mode to work with EMA files. This automatically selects the correct node in the structure tree when you make a selection in the 3D view. If you want to visually improve the simulation now, we can customize some settings. For example, if you export models from EMA that contain transparency, the checkbox Translucency under Render Settings Ray Tracing must be set. Since the labels of the cycles do not yet look as they should, we can make one more setting that will make two-sided labels from EMA look better. Therefore, we have to set the checkbox under Render Settings Common at Backface Culling. Another option to make our simulation look better are numerous materials in the library. To use them, search for the desired texture in the Materials tab. For example, I want to enhance the wooden floors, so I search for wood here. Then I click on the desired object, in this case the floor cuboid, and drag the material onto this selected object. Let's do the same with the other two floors. The materials library, for example, also offers more appealing car paints, and so I search for paint and drag the car paint to some of the chassis. Now the scenario looks much better and we can make screenshots and videos. For this we use the extension Movie Capture, which we can find under Window, Rendering, Movie Capture. Here a new window opens, which we place at the right edge of the screen. To capture a screenshot, it's also useful to activate the timeline under Window, Animation, Timeline. If we now want to take a screenshot, we simply drag the timeline slider to the desired frame and specify the desired save path in Movie Capture. We recommend path tracing as the setting for the render preset. Then we click on Capture Current Frame. And there is our high-quality screenshot. To create a video, we also go to the Movie Capture tab. Here we can specify the desired frame rate. In my case, I choose 60 frames per second. We can also specify the desired resolution and rendering settings here. Now I enter a name for the video and click on Capture Sequence to start the rendering. Here we are, the video is rendered and saved in the selected path. This brings us to the end of this part of the tutorial. We have learned how to transfer an EMA scenario to the Omniverse, make adjustments there, and finally create screenshots and videos. Thanks for watching. See you next time.